Dear students, welcome. This is our 7th class on hydrostatics. Today we shall discuss a new chapter, thrust on plane surfaces. Thrust on plane surfaces. First of all, we shall discuss a theorem. The statement of the theorem is the pressure of a heavy homogeneous liquid on a plane area is equal to the product of the area and the pressure at its center of gravity. This means the thrust of A, not on A, of A, the thrust of A, heavy homogeneous liquid on a plane area is equal to the product of the area and is equal to the product of the area and the pressure at its center of gravity. Pressure at each center of gravity. What is this? The thrust of a heavy homogeneous liquid on a plane area is equal to the product of the area and pressure at its center of gravity. Means pressure, first find the center of gravity of the area, then the pressure, the product, you should multiply the area and the pressure. This will be the thrust of on the plane area. Suppose S is a plane area immersed in a heavy homogeneous liquid of density O. Suppose A is a, I am writing slightly bigger than this, Suppose S is a plane area immersed in a heavy homogeneous liquid of density O. Suppose A is a point within S. A is a point within S. Suppose BC is the effective surface. Z is the depth of A below the effective surface. Z is the depth of A below the effective surface. Z is the depth of A below the effective surface. Consider an elementary area. Suppose this is delta S. Consider an elementary area delta S at A. First, let me write delta S at A. Then, what will be the thrust on this area S? Will be equal to the product of S into the center of gravity of S. You find the center of gravity of S. Suppose it is at a depth Z bar below the effective surface. What will be the pressure of this? Pressure of the center of gravity? G rho into Z bar. This means that the thrust will be equal to S into that pressure. Pressure means G rho Z bar. Let me write first. Let S be the plane area. Plane area. Immersed. Let S be the plane area immersed in a heavy homogeneous fluid. Homogeneous fluid. Homogeneous fluid or liquid of density rho. Let S be the plane area immersed in the heavy homogeneous liquid of density rho. Next, let A be a point within S. Let A be a point within S. point within S. Let A be a point within S. Now consider an elementary area, delta S. Consider an elementary area. Elementary area. Area. Delta S at A. Delta S at A. Suppose Z is the depth of A below the effective surface BC. Let Z be the depth of A below the effective surface. Effective surface. Z be the depth of A below the effective surface, suppose BC. BC. Therefore, pressure at A. Now the pressure at A. Pressure, suppose P at A. Pressure P at A is given by P equal to pressure at A. P equal to 0 into the depth of the point A below the effective surface Z. 0 Z. 0 Z. Thrust on the elementary surface. Therefore, thrust on the elementary area delta S will be equal to thrust on the elementary area will be equal to thrust pressure into area. Pressure into area. This is equal to pressure means P into delta S. Area is delta S. What is P? 0 Z. 0 Z delta S. Pressure on the elementary area. Therefore, thrust on the whole area S. Therefore, thrust on the whole area S will be equal to, definitely it will be summation 0 Z delta S. Zero Z delta S. Thrust on the whole area will be equal to the summation of this. This is equal to 0 can be taken outside this summation. 0 summation Z delta S. It will be this. Now, what is our aim? We have to show that the thrust on the whole area S should be equal to S into the pressure at its center of gravity. Means, if the center of gravity of S is Z, S is suppose G, we have to find the depth of G, the center of gravity, below the effective surface. Below the effective surface. Then the pressure will be definitely 0 Z bar, if Z bar is the depth of the center of gravity below the effective surface. Suppose let Z bar be the depth of the center of gravity G. Center of gravity of S. Z bar be the depth of the center of gravity of S below the effective surface BC. Below the effective surface BC. Z bar be the depth of the center of gravity of S below the effective surface BC. Therefore, Z bar. Therefore, Z bar center of gravity. Therefore, Z bar. This should be equal to summation of Z delta M divided by summation of delta by definition. This is equal to summation Z delta S into sigma, suppose. Summation delta S into sigma. Where sigma is the mass per unit area, where sigma is the mass per unit area. Per unit area of S. Suppose sigma is the mass per unit area. Per unit area. This is equal to summation Z delta S divided by summation delta S. This is equal to summation Z delta S divided by, this is nothing but S. Summation delta S is S. This means Z bar equal to summation Z delta S divided by S. This means summation Z delta S equal to Z bar into S. Z bar into S. Z bar into S. Now, thrust on the whole area S. Now, thrust on the area S equal to. Now, thrust on the area S. Now, thrust on the area S equal to 0 summation Z delta S, which is equal to 0 for Z delta S, summation Z delta S, you may replace it by Z bar delta S. Z bar S. This is equal to 0 Z bar into S. What is 0 Z bar? It is the pressure at the center of gravity of S. This is equal to the pressure at the center of gravity of S. Center of gravity of S into the area of S. S stands for the area of S. Area. Thus, we have put this one. Therefore, thrust on the area equal to thrust on the plane area equal to the area into the pressure at its center of gravity. Therefore, thrust on the plane area S equal to the product of the area and the pressure at its center of gravity. The pressure at the center of gravity of S. Pressure at its center of gravity. This is the theory. When when a plane area is immersed in a liquid, if you are to find the thrust on that area, then you should find the area, into area. You should multiply that area by the pressure at the center of gravity of that area. This is the theorem. Very interesting theorem, and this theorem will be applied. First, let us take one problem of this. Let us solve this problem. What is this? A hollow weightless cone of vertical angle alpha is filled with fluid and suspended freely from a point on the rim of its base. Suppose I am writing here. It is the base of the cone. Suppose you know who is the vertex of the cone. Suppose it is horizontal in the effective surface. Horizontal. It is horizontal. And C is the center of the base. Alpha is this. and suppose A is the radius of the base, H is the height of the cone, H is the height of the cone. Not only that, suppose G is the center of gravity of the cone. Suppose this is D and E. DE is horizontal, and the radius of the base makes an angle theta. Consequently, this angle is theta. This angle will be equal to 90 degree minus theta, and this angle will be equal to obviously theta. Obviously theta. Also, obviously theta. This is theta. Let me write. The vertical angle of the cone is alpha. It is given in the question. With fluid and suspended freely from a point on the rim of its base. From the point A, it is suspended from the point A. Suppose the thrust on the base. We have to find the thrust on the base. Thrust on the base. And we have to find the weight of the fluid within the cone. These two things will have to be calculated. First, thrust on the base, number one. Number two, the weight of the fluid within the cone. Then we have to find the ratio of these two. Thrust of the base, thrust on the base of the cone, base, thrust on the base, and weight of the cone. Then find the ratio. You should show that the ratio is 12 sine square alpha divided by 12 sine square alpha is to cos alpha into this one. Cos alpha into this one. Very simple. Let me first write. Let AU be the cone. Let AU be the cone. With OS vertex. With suppose OS vertex as its vertex. Vertex of the cone is this. Let C be the center of the base of the cone. Right? C be the center of the base of the cone. Center of the base of the cone. Let alpha be the vertical angle of the cone. It is also given in the question. Let alpha be the vertical angle. Vertical angle of the cone. Alpha be the vertical angle of the cone. Right? It is also. Let A be the radius of the base of the cone. Let A be the radius. Radius of the base of the cone. Means AC, this distance AC will be equal to, A will be equal to A. What we are going to show? First, we should find the thrust on the plane base. Thrust on the plane base. Also, the cone is suspended from the point A. Let the cone be suspended from the cone be suspended. Suspended from the point A. From the point A. Suspended from the point A. This one. Also, let DAE be horizontal. Right. Let DAE be horizontal. Horizontal. EAC, suppose let angle EAC. This is equal to theta. EAC is equal to theta. Means this horizontal line makes an angle theta with the radius or diameter of the base of the cone. Base of the cone. Also, you see, AZ is vertical. AZ is vertical. This angle is theta. It is vertical. DAE is horizontal. DAE is horizontal. Therefore, this angle is GAC will be equal to 90 degree minus theta. Also, OCA, this angle is 90 degree. Therefore, AGC angle will be equal to definitely theta. Therefore, let G be the CG of the bone. Let G be the let G be the CG of the bone. AG is vertical. AG is vertical. Angle AGC equal to theta. Therefore, angle AGC, this is equal to theta. Angle AGC will be equal to definitely theta again. Up to this, it is clear. Suppose, yeah, I think it is clear up to this point. Now come to the main point. What is our main point? We have to find the thrust on the plane base. Thrust on the plane base. Thrust on the base of the bone. Thrust on the base of the bone. First, we have to find this one. Next, we have to find the weight of the fluid within the bone. Weight of the fluid within the bone. These two things will have to be calculated. Let me be the thrust on the base of the bone. Thrust on the base of the bone. Just remember the theory. The thrust on a plane area. This one, C, it is a circle. C is the radius, and AC is C is the center. AC is the radius. AC is the radius. Thrust on the plane area is equal to the product of the area. What is the area of this circle? A is the radius. Pi a square. Pi a square. This will be the area. And product means into the pressure at its center of gravity. What is the center of gravity of the plane base? C, the center. What is the pressure at C? We have to find the pressure at C on the plane base of the plane. Therefore, T equal to T. This is equal to pressure at C. Pressure at the center of gravity of the plane base C into the area. Into what is the area of this? Pi square. Because A is the radius of the base of the A is the radius of the base of the. Since A is the radius of the base of the bone. Since A is the radius of the base of the bone, pressure at C will be equal to G rho, and the depth of the center of gravity, C, below the effective surface. This distance, we will have to find this distance, 0 into this distance. What is this distance? It is 90 degree. From this to this, it is A. This to this, it is A. It is theta. What will be this? This will be equal to A sin theta. It is definitely A sin theta. 0 A sin theta. 0 A sin theta is not it. The pressure at the center of gravity is 0 A sin theta into pi square, where rho is the density of the homogeneous liquid. You may write here where rho is the density of the, where rho is the density of the homogeneous liquid. Where rho is the density of the homogeneous liquid. I hope up to this step, this weight of the fluid within the will be. This is equal to 0 pi a cube sin theta. T is equal to this. Thrust on the plane base has been calculated as 0 pi a cube sin theta. Now we have to find the weight of the fluid within the cone. Now, weight of the fluid within the cone. Just let me give you the chance to write down this. I hope you have copied everything. Now, let W be the fluid within the cone. Within the cone. Therefore, W, this is equal to fluid within the cone. Weight equal to mg. Mg. Just write G. Means we have to find the mass of the fluid within the cone. Rho is the density of the homogeneous liquid. Rho is the density of the homogeneous liquid. Rho. We have to find the volume of the cone, of the fluid within the cone. What is the volume of a cone? 1 by 3 pi a square h. 1 by 3 pi a square h. H is the height of the cone. Where h is the height of the cone? Is the height of the cone. Of the cone. H is the height of the cone means OC is equal to H. That is OC is equal to H. Height of the cone is this. Height of the, right? Weight of the fluid within the cone, G. You have to find write down the mass. Rho has already has been written here. You have to find the volume. What is the volume of the cone? 1 by 3 pi a square h. 1 by 3 pi a square h. Now you see, you have calculated T, you have calculated W. Now we have to find the ratio of T and W. Therefore T is to W. Therefore T is to W equal to T by W. What is T? 0 pi a cube sin theta divided by 1 by 3 pi a square h rho z. Now pi will be cancelled. Z rho will be cancelled. This is equal to a square and a cube will be cancelled. Only a will be there. Thrice a. This is equal to thrice a sin theta divided by h. Thrice a sin theta divided by h. Thrice a sin theta divided by h. T is to W equal to this. T is to W equal to this. Suppose I am writing here number 1. Mark it as number 1. Now tan alpha. Tan alpha equal to. Consider the triangle OAC. OAC. This is alpha. Vertical angle of the cone is alpha. This is equal to AC divided by OC. Equal to AC by OC. What is AC? AC equal to A. Radius of the base of the cone and OC equal to height of the cone. This means A equal to H tan alpha. A equal to H tan alpha. A equal to H tan alpha. This is number 2. Suppose this is number 2. Now, using 2 in 1 we get. Using 2 in 1. Using 2 in 1 we get. 1 we get. Using 2 in 1 we get. T is to W. We have to find this one. T is to W equal to 3H tan alpha sin theta divided by H. This means T is to W equal to thrice tan alpha into sin theta. Thrice tan alpha into sin theta. Suppose this is number 3. And in the final answer you see, what is 12, 13, 14, you ignore this one. It is sin square alpha. And sin square alpha, cos alpha, 15 sin square alpha. What is mean? What does it mean? Alpha is there. Simply alpha is there. This means here it is tan alpha, no problem. It is sin theta. Means sin theta should be replaced by alpha. By alpha. Thus sin theta should be replaced by alpha. Now see here. From the triangle ACG, ACG, sin theta equal to, no, ACG, tan theta is equal to, perpendicular by base, AC by CG, This is equal to, what is AC? AC equal to small a, CG equal to H by 4, 1 by 4H. This is equal to 4A divided by H. Tan theta is equal to 4A divided by H. This means tan theta equal to 4H. What is A? Just we have in the tan alpha equal to A by H. A is equal to H tan alpha. A replace A by H tan alpha. This means tan theta equal to 4 tan alpha. Tan theta is equal to 4 tan alpha. You have got tan theta. Convert this to sin theta. Simple. Convert tan theta to sin theta. For that we have to write, suppose tan square theta equal to 16 tan square alpha. Tan square theta is equal to 16 tan square alpha. Now, I should not remove this one because this will have to be proved. 16 tan square alpha. This means, and number 3, we have to substitute sin theta here. Therefore, this is number 3. This means sin square theta divided by cos square theta. This is equal to 16 tan square alpha. This means sin square theta equal to 16 tan square alpha into cos square theta means 1 minus sin square theta. 1 minus sin square theta. This means sin square theta, this sin square theta into this. Just take it to the left hand side. 1 plus 16 tan square alpha into sin square theta. This is equal to 16 tan square alpha. This means sin square theta equal to 16 tan square alpha divided by 1 plus 16 tan square alpha. 1 plus 16 tan square alpha. Sin square theta is equal to this. This means sin theta equal to 4 tan alpha divided by root of r 1 plus 16 tan square alpha. 1 plus 16 tan square alpha. In the final result, you see here sin theta and cos theta is there simply. Therefore, you write 4 sin alpha by cos alpha divided by root of r 1 plus 16 sin square alpha by cos square alpha. Cos square alpha. This is equal to 4 sin alpha divided by multiply by cos alpha. Here you will have to write cos square alpha. Within the radical sign it will be 16 cos square alpha plus 16 sin square alpha. Cos square alpha plus 16 sin square alpha. 16 sin square alpha can be written as sin square alpha plus 15 sin square alpha. Cos square alpha plus sin square alpha equal to 1. Therefore, it will be equal to 4 sin alpha divided by root of r 1 plus 15 cos square sin square alpha. 15 sin square alpha. 4 sin alpha divided by root of r 1 plus 15 sin square alpha. Sin theta is equal to this. Just substitute sin theta. Therefore, sin theta equal to this. It is number suppose 4. This is number 4. Substituting the value of sin theta from 4 in 3 we get. Substituting the value of sin theta from 4 in 3 we get. In 3 we get. T is to W equal to 3 tan alpha. Sin theta means 4 sin alpha divided by root of r 1 plus 15 sin square alpha. 1 plus 15 sin square alpha. This is equal to 12. 4 into 3, 12. It is sin alpha by cos alpha into sin alpha divided by 1 plus 15 sin square alpha. It will be like this. This is equal to 12 sin square alpha divided by cos alpha into root of r 1 plus 15 sin square alpha. Sin square alpha. Therefore, you see 12 sin square alpha divided by this. This is equal to this. That's good. Equal to 12 sin square alpha is to cos alpha into root of r 1 plus 15 sin square alpha. Proved. T is to W is equal to this. Proved. We have proved this. You see, it is very easy. Just we have applied this one. Thrust on a plane area equal to the product of the area into pressure at its center of gravity. This theorem has been applied. Pressure at this equal to the area of the circle whose radius is A is pi square. Just multiply this by the pressure at its center of gravity. The center of gravity of a circle is the center. What is the pressure at its center? At the center C. You see G rho. Rho is the density of the homogeneous liquid. G rho into this distance. This distance, the vertical distance of C from the effective surface A equal to A sin theta. Just we have applied this one. Perhaps you have enjoyed this one. Now let us take another problem. Let us try to solve this problem. What is this? A rectangular area is immersed in a heavy fluid with sides horizontal. And is divided by horizontal lines into strips on which mark this, on which the total thrust are equal. Prove that if ABC are the breadth of 3 consecutive strips, Then we have to prove this one. Prove this one. A rectangular area is immersed in a heavy fluid with sides horizontal. Sides horizontal. Suppose ABCD be the suppose ABCD be the rectangular area. ABCD rectangular area is immersed in a homogeneous liquid of density, suppose so. Density. The breadth of the rectangle is T. Breadth of the rectangle is T. Now, horizontal line distribution. Horizontal lines, we have to horizontal lines into strips. Horizontal lines, horizontal lines into strips. And we are given there, ABC are the breadth of 3 consecutive strips. This one, the breadth of this is A, breadth of this strip is B, and breadth of this is C. Consecutive strips is ABC. Suppose this is the effective surface, LM is the effective surface, and this distance is D, AD, this distance, the the breadth of the rectangle is D. Suppose this distance is X, and thrust, total thrust on which the total thrust are equal on the strips. This is suppose this is T1, T2, and this is T3. Thrust on this strip is T1. Thrust on this strip is T2. Thrust on this strip is T3, and these thrusts are equal. T1 equal to T2 equal to T3. This thrust equal. Now let me write first. Let me write down. Let ABCD be the horizontal area immersed in a heavy liquid of density. Write like this. Solution. Let ABCD be the rectangular area immersed in a heavy fluid of density. Let ABCD be the rectangular area immersed in a heavy fluid of density. Let D be the breadth of the. Let D be the breadth of the rectangular area. Now, horizontal lines, we have to draw the horizontal lines. After drawing the horizontal lines, three strips. Strip 1, strip 2, strip 3. You may write here strip 1, strip 2, strip 3. This is strip 1, it is strip 2, and this is strip 3. Two strips. And you are given that ABC are the breadth of the. Let ABC be the breadth breadth of the strips. Let ABC be the breadth of the strip 1, strip 2 and strip 3 respectively. Strip 1, strip 2 and strip 3 respectively. Let X be the right. Let X be the depth. Let X be the depth of the upper surface of the liquid. Surface of the liquid or fluid? We have written fluid. I think fluid, therefore, if we write here fluid also. Same thing. It is not a problem about surface of the fluid of strip 1. Upper surface of the strip 1, this one. Let T1 to T2, T3. Let T1, T2 and T3 be the thrust on the strip 1, strip 2 and strip 3 respectively. Strip 3 respectively. T1, T2, T3 are the strips. And we are given that T1 equal to T2 equal to T3. T1 is equal to T3. Now the interesting things are coming. You see, the strip 1 is nothing but a rectangle of length. This is D. Length D and breadth A. What is the area of strip 1? It will be A into D. A into D. It will be this. And the middle point will be definitely, will be definitely the center of gravity of the strip 1. Now, T1 is thrust on the strip 1. You see, thrust on the strip 1. Then, use the theorem. What is the theorem? The thrust on the strip will be equal to pressure at its center of gravity. What is the center of gravity of the strip 1? This is the middle point, suppose. Middle point will be the center of middle point of the rectangle, which is strip 1. What is the center of gravity? What is the pressure of this? 0 into this distance from the effective surface. This and this is H. What is this distance? It will be definitely A by 2. Because the breadth of this strip is A. It will be A by 2. 0 X plus A by 2 is the pressure. Is the pressure at the center of gravity of the strip 1. Into the area, what is the area of strip 1? A into D. We have to write. Very interesting. Now T1 equal to pressure at the center of gravity of strip 1. Pressure at the center of gravity of C1, center of gravity of strip 1 into area of strip 1 into area of strip 1 is not it. This is equal to the pressure at the center of gravity is 0 into depth of the middle point of the center of gravity of strip 1 below the effective surface is x plus a by 2. It will be x plus a by 2. X plus a by 2 into area of this is AD. This is equal to it. Perhaps rho is the density of the homogeneous liquid. If you have not written this, right, rho is the density of the homogeneous liquid. Of the homogeneous fluid. Rho is the density of the homogeneous fluid. T1 is equal to 0 x plus a by 2 into AD. Rho is the density of the homogeneous fluid. T is equal to, similarly T2 is equal to, T1 is equal to this. Similarly T2 equal to, T2 equal to, what is the pressure at the center of gravity of strip 2? 0 into depth of strip 2 below the effective surface, x plus a plus b by 2. It will be equal to x plus a plus b by 2 into area of strip 2, length into breadth, b into d, equal to bb. And T3 equal to definitely 0 x plus a plus b plus c by 2, x plus a plus b plus c by 2 into CD. It will be the thrust on the strip. According to the question, the total thrusts are equal on the strips. T1 equal to T2 equal to T3. According to the question, T1 equal to T2 equal to T3. According to the question, T1 equal to T2. This is equal to T3. T1 equal to T2 equal to T3. This means T1 is equal to 0 x plus a by 2 AD. This is equal to x 0 x plus a plus b by 2 into BD. This is equal to 0 x plus a plus b plus c by 2 into CD. This means x plus a by 2, 0d will be cancelled from x plus a plus b by 2 into b. This is equal to x plus a plus b plus c by 2 into c. It will be like this. From this relation, we have to prove this one. No hydrostatics is there. You have to prove that. What is this? You have to find the relation between A, B, and C, and that relation will be equal to this. A into A plus B into B minus C. X will be eliminated. To eliminate X, taking the first two we get. First, let me write what we are going to prove this. A into A plus B into B minus C equal to C into B plus C into A minus B. We are going to prove this one. We are going to prove this one. Can I remove this? Yes. Taking the first two we get. The first two we get. X plus A by 2 into A, X plus A plus B by 2 into B. This means X into A minus B, X into A, X into B, X into A minus B. This is equal to AB plus B square by 2 minus A square by 2. Minus A square by 2. Or you may write here twice X into A minus B equal to twice AB plus B square minus A square. And write it as number 1, suppose. Write it as number 1. Twice X, A minus B equal to this one. Taking the last two, what is this? X plus A plus B by 2 into B. This is equal to X plus A plus B plus C by 2 into C. This means X into B minus C. X into B minus C. This is equal to AC plus BC plus C square by 2 minus AB minus B square by 2. You may write like this. This means twice H into B minus C. This is equal to twice AC plus twice BC plus C square minus twice AB minus B square. Suppose this is number 2. If you divide 1 by 2, then X will be eliminated. 1 divided by 2. Dividing 1 by 2. 1 by 2. X will be eliminated. Twice X into A minus B divided by twice X into B minus C. This is equal to twice AB plus B square minus A square divided by twice AC. This will be cancelled. This means A minus B minus C into cross multiplication. B square minus A square equal to A minus B into twice AC plus twice BC plus C square minus twice AB minus B square. It will be like this. Now, what is our aim? It is not the, from this onwards, it is not the question of hydrostatics. It is a problem of class 9 or class 10. It is a problem of class 9. From this relation, prove this. It is given T1 equal to T2 equal to T3. These are given. We have to prove this one. This question is what we are doing now from onwards. The things we are going to do is not of hydrostatics. Just simple mathematical calculation. Simply mathematical calculation. How can you prove this one? B minus C, A into A plus B is there. Therefore, you may write here B minus C, A into A plus B is there. You will have to write minus A into A plus B also, plus twice AB plus B square minus A square. Can I write like this? In the left hand side. And in the right hand side, A minus B into, it is C into B plus C, right? C into B plus C. And C into minus C into B plus C also have to be written. C minus C into B plus C. Next, write this one. Plus twice AC plus twice BC plus C square minus twice AB minus B square. This means this into this, A into A plus B into B minus C, plus this B minus C is there. It will be minus A square minus AB plus twice AB plus B square minus A square. Now write the right hand side. This is equal to C into B plus C into A minus B, C into B plus C into A minus B, this one, plus A minus B into minus BC minus C square plus twice AC plus twice BC plus C square minus twice AB minus B square. This means it is this A into A plus B into B minus C here plus B plus C, B minus plus B minus C into from this AB plus B square minus twice A square can be minus twice A square. This is equal to, it is C into B plus C into A minus B plus A minus B into minus BC plus B, twice BC. It will be plus BC. Plus C square minus C square will be cancelled. Twice AC is there. Minus twice AB is there. Also minus B square. This also minus B square. See the calculation. Beauty of the calculation. You see, we have to prove this is equal to this. What does it mean? These two terms will be cancelled. This term and this term. These two terms will be cancelled. You see, B minus C is there. A minus B is here. Therefore, another A minus B must be here in this, within this bracket. A minus B must be a factor of this term. A minus B must be a factor of this term. Also here B minus C must be a factor of this term. A into A plus B into B minus C plus B minus C into A minus B is a factor. A minus B is a factor. Therefore, you will get minus A square plus AB minus A square plus B square. You may write in this way. This is equal to C into B plus C, A minus B plus A minus B into, here B minus C must be a factor of this. B minus C. B minus C. Therefore, you may write B square plus BC. B square plus BC. Minus twice AB plus twice AC should be there. Yes. This means A into A plus B into B minus C plus B minus C into minus A into A minus B minus A plus B, A square minus B square means A plus B into A minus B. You may write like this. This is equal to C times of B plus C into A minus B minus B times of B minus C from this. B times of B minus C minus twice A into B minus C. You may write this means A into A plus B. Minus minus can be taken outside. Minus B minus C into A minus B. Here it will be A plus B means twice A plus B. Twice A plus B. This is equal to, you write here C into B plus C A minus B minus minus common minus A minus B, right? B minus C also you may write B minus C. It will be B plus twice A, or twice A plus B or B plus twice A. B plus twice A. You see here these two terms will be cancelled. These two terms will be cancelled. Therefore, it will be A into A plus B, B minus C. This is equal to C into B plus C, A minus B. Proved. Hence proved. It is proved. Perhaps you have enjoyed this. Dear students, I want to stop here. Thanks for attending the class. Thank you very much. Thank you.